Hello everyone, welcome to a new video. Today we'll look into bias and variance. These are some terms which we come across very frequently. So let us dive deep. What is a bias? A bias is nothing but an error or the average difference between the prediction and the actual terms. Or difference between predicted and actual terms or actual points in data. Now, how does this look like in a machine learning scenario? Suppose we have data points spread across like this, and we try to train a linear regression model on these data points, and say the regression line looks like this. Now we see that our regression model is unable to understand the data well and is not able to mimic the data. That means it is too simple. Our model is too simple to understand the data, and also there is a high error. If we cumulatively add up the errors, it comes out to be quite large. That is, there is a high error. So this model exhibits high bias. So we see 2 points over here. That is, the model is too simple to even understand the data while training. So this we see during training. That is, the model fails to even train on the data, and this is called high bias. Now what does high bias lead to? High bias leads to something we know as underfitting. So what are the different models that suffer from underfitting? Namely, a few that are linear regression, logistic regression, and a few more. These are the most notoriously ones that suffer from high bias or underfitting. So what is the solution of a high bias model? Well, if we see that a model is exhibiting high bias, we have no option but to go with a different model for that particular data. That means for that particular data set, the model that we are using to train it is not sufficiently smart enough. Now let's go to variance. What does variance mean? Variance is nothing but the variability of the model performance or prediction when a new data point is given to it. That is, the difference in performance of a model between the training and test sets. Let's visualize it. We have data points spread across like this. Now suppose we train a deep neural network on these points. Now we see that the points are quite well mimicked or quite well traced by our model during the training phase. Now we try to test the same model on a new set of data. Now we see that the performance diminishes when we give it a new set of data. So this difference in performance or prediction of the same model on two different sets of data is known as variance. So this huge difference leads to the model to have high variance. Now what does high variance lead to? High variance leads to something we know as overfitting. which means our model is kind of memorizing the data while training and not able to generalize well. Hence, when we give it new data to test it upon, it fails. That is, the model is not generalized well enough. It memorizes or is very well suited or trained very well and performs very well. I wouldn't say trained very well, it performs very well on the training data, but due to lack of generalization, it doesn't transfer well when new data points are given to it for testing. So what are the different models which suffer from overfitting? Namely, SVM, support vector machines, K nearest neighbors, KNN, neural networks, and decision trees. So what is the solution for a model having high variance? Namely, for different machine learning algorithms, we can go for something known as regularization, which kind of helps in reducing the overfitting to a certain extent. For deep learning models, we can go for something known as dropout. So now we know what a bias and variance is, and what high bias leads to and what high variance leads to. Namely, high bias leads to underfitting and high variance leads to overfitting. But how should our perfect model or ideal model look like? The ideal model should have low variance, that is, it should generalize well and perform well for both the training and the test set, as well as low bias, meaning it should not be too simple to understand, or it should be smart enough to understand the data well. That is, it should be able to understand the data while training. Also, it should be generalized enough to perform similarly on the testing set. So the ideal model has low variance and low bias. That's all for today. I hope you liked it and enjoyed the video. Don't forget to like, share and subscribe. Thank you.